Do you ever question whether the sun will rise the next day or whether there will be sunset this evening? No, because you know that the event of sun's rising and setting have a fixed structure of recurrence at a fixed rate. We are guaranteed that the sun will rise and set in every 24 hours. The exact time of sunrise and sunset may differ, but still the events sunrise and sunset are guaranteed to occur at that same rate. Wouldn't it be nice if there were more such fundamental guarantees for other aspects of our lives, like good health, loving friends and family, world peace every single day? But we know that's not that certain. On the other hand, it's also better for some events to not occur that often. For example, car accidents, tornado, earthquakes, wars. While such events are disruptive with varying intensity, we would also like to be able to predict when they may occur in order to be prepared to minimize their negative impacts and to come up with Plan B. So today, we are going to learn some principles of how some events are studied to make future predictions about their occurrences. While not every event may be predictable, for example, whether you will experience random act of kindness or a road rage may not be predictable at an individual level. Neither did anybody predict that there will be worldwide coronavirus pandemic in 2020. Those are examples of events that have no set patterns of recurrence like we saw in sunrises. However, we all know that natural disasters, traffic jams do occur, and we have also learned when to expect traffic jams, when there is a popular event nearby, or when it's raining heavily, construction work. Either one or combination of these tells us what to expect in our commute today. So we know that occurrence of one or more events affect the other event, your arrival time at your destination. So you already know a few basic concepts of probability. Event, its occurrence, its dependence on another event's occurrence, the rate of occurrence of the events. See, you're not a total newbie in probability theory. Okay, let's build some more vocabulary terms. Say before getting on the highway, you do not know exactly which cars and how many of them will pass by yours. This is an example of observing something uncertain, which is called a random experiment. If we note down some numerical aspects of the random experiment, we can use it to hypothesize or predict some future occurrence of the event. For example, consider traffic on 101 passing through Palo Alto and Sunnyvale between 8 to 9 a.m. as a random experiment. You intuitively know that only counting the number of cars on 101 on a single day is not enough to make any general statements about the 101 traffic. Instead, you know you will need at least a few weeks worth of data. So, if you and your two friends count the number of cars on the road for 4 ordinary weeks over the overbridges on these cities, each of those daily counts give us some information about the outcome of that random experiment. Those daily counts are called as random variables. In general, for a random experiment, we have multiple random variables over a period of time, which is basically intermediate numerical values of the experiment over time. Now, you can imagine that you will start noticing a pattern in your counts. So if somebody asks you to predict the number of cars on Wednesday of the fifth week, you can give an approximation number of expected cars based on your recorded data of 4 Wednesdays. Similarly, if somebody asked you what is the possibility of seeing 157 cars from Palo Alto's overbridge, you would want to be able to use the data to predict that there is, say, 40% possibility. So how do you compute such possibilities? First, we'll have to establish some relationship between the recorded data and the question at hand, so that if we feed in the value from the question, it gives us the probability of seeing that value by making use of the recorded data. This relationship is called probability mass function. Mass because it tells us how much probability is involved, and function because that's what we use in math to represent such relationship. So the PMF is a measure that gives us the probability of the possible value for a random variable. Using the PMF, If we assign a probability to each possible outcome of a random experiment, we get a probability distribution. So here, we see that there is more likelihood of seeing 250 cars in our experiment in the Sunnyvale than in Palo Alto. A probability distribution is a mathematical function that describes the probability of different possible values of a random variable. Building on that, a random process is a sequence of random variables' values over a period of time or space, where each random variable can take on a different value from some probability distribution. Okay, let's take a relaxing breath and congratulate you for having learned new terms like random experiments, random variables, PMF, probability distribution, random process. Yay! Now go on, read the accompanying write-up to learn about something called the Poisson process. It is a random process that is used when an event with countable outcome occurs at a known rate, but the exact timing of the events is random. Happy learning!